First off, 2 weeks from today, on April 2nd, we won't have class that day. I'll have a YouTube video out there, a tutorial for a particular topic in Unity, and the project will be to finish that tutorial. So you just kind of follow along with the tutorial. My son's being operated on that day, so I definitely won't be in class on the 2nd. Now, if you are in the Monday and Wednesday class, and then we'll be doing the same thing in the daytime class here. Now, my son is supposed to have a surgery on the 2nd, and supposed to come home on the 3rd, assuming no complications. But I know how that works. They never let you go first thing in the morning. Probably late afternoon before he actually gets released. So my 4 o'clock class, 7 o'clock class, I'm planning on conducting those from home with Zoom. But if something does come up, then I'll do something similar where I'll give you an alternate project on that, if you're in one of those 2 classes. Now I'm going to bring up Visual Studio. From Visual Studio, if I just start typing Visual Studio here, it'll load it. We've added load automatically from Unity. So click that there. We're going to do some reviewing. This is in preparation for a test. I put a test out there before class. And the test is a programming-based test. I'll go ahead and talk about it. It's 3 questions. There's a question on the if-else construct. There's the for and the while loop. Now, we have not really focused a whole lot on the for loop and the while loop, so I wanted to make sure I reviewed that, and Unity does a lot of those for us. For example, each time through a frame, it's running those updates. Or first time it creates an instance of that class, it'll run that start. So it's doing the looping for us. We just don't see it. And we haven't had to control a lot of that via code. So I wanted to spend time on that to refresh your memory before the test. You can do the test in Visual Studio or Unity, or I guess those are the 2 main ones. If you do it directly in Visual Studio, we'll see a couple of new commands you need to know, which I believe you saw at the beginning of the semester. If you do it through Unity, that, of course, works in conjunction with Visual Studio. And you can write your answers out to remember the canvas. You can write it out to the canvas and whatever component you want. You could even print it to the console when the game's running. So there's a few options there. What you're going to turn in on each one of the problems is you turn your code. So after you get your code done, you'll edit, copy it, you'll edit, paste it, and you'll put the answer if there is one. 2 of the 3 problems will ask you for the numeric answer. So you want to make sure you put that. So if the numeric answer is 300, then you want to put 300 down below the code. You get graded for both parts, having your code and the answer. Of course, the main goal is to see your code, so don't forget to put your code in there, because that's I'm not wanting just the answer, but the idea is the code. Each one of the questions is essay format. Each one's worth 60 points. This is part of our accreditation. They sat down with all the different programs and said, what do you want people to know coming out of your program in terms of in my area, that was thinking of programming skills. Well, I want them to know how to do an if-else statement, I want them to know how to do a for loop, and I want them to do a while loop. So those are the 3 main ones. Last semester, in the game development and the computer animation, which both had programming involved in them, students didn't do well on this test because just like you've been seeing, Unity doesn't use a whole lot of for loops and while loops. Now, the due date on this is not until Sunday night, so you have a little bit of time. If you want to practice on for loops and while loops before you get into the test, you can. I'm going to show you examples here to help prepare you. It is timed. You get 80 minutes to take the test. So after you start it, then you got 80 minutes to finish the programming project and paste it in along with your answer. So don't start the test and then go off to lunch and think I'll just do it when I get back. Make sure you have that 80 minutes dedicated there, because it will automatically submit after that 80 minutes. It is located in the current weeks folder, so if you go to look for it. And it's not my idea. I don't like tests, but it's part of the accreditation where we got to have some kind of measure to what are our students learning coming out of the programs. Okay, now I went into the Visual Studio directly here, and I'll do a File, New, and choose Project. Under, I guess I have Windows Desktop highlighted, but you can probably choose different options here. We want to choose a console app .NET framework. Give it whatever name. And we'll write a program that asks you your salary, and we'll figure the taxes based upon a certain amount. I don't know if I could actually get the real amounts from the internet, so I may make up some. A lot of people don't understand how the tax system works. My wife has got on me in the past saying, well, don't make any more, because if you make any more, throw us in the next tax bracket. And you hear that a lot. Well, that's not the way it works. You have a tax bracket that maybe goes from 0 to 30,000, is taxed at, I'm again making this up, 20%. And then, $30,000, $1 to 50,000 is taxed at 25%, for example. Put some commas in there, make sure I got that illustrated. Like that. Well, I'm making more than 29,000, but let's say I was making 20,000, 29,000. Well, since it's between 0 and 30,000, then my tax would be 29,000 times 0.20, whatever that give me. Pretty straightforward. Let's say I start making more money. And I make 40,000. Well, what my wife viewed this as is that you take the 40,000, you'd multiply it times the 0.25. And so by making more money, that was going to hurt us. That we needed to be down the previous tax bracket. And no, that's not the way it works. What happens is the first 30,000 is taxed at 20%. Then the next $10,000, since we're making 40,000 now, the next 10,000 is taxed at 25%. So it doesn't actually hurt you to make more money. This, no matter what, is the first 30,000 is automatically taxed at that. The remaining amount, 40,000 minus 30,000 would give us 10,000, is taxed at the next percent. This is why the tax system is a little bit challenging. Besides all the the exemptions and so forth, not exemptions, deductions and so forth, is because if it's just a straight percent, we look up your salary, it says it's all going to be at this percent, all going to be at this percent, all going to be at this percent, and then it'd be easy to figure. You may have heard that they're talking about. I've heard one plan of taxing rich people at 70%. I think I heard 90% from one candidate. Of course, they're just trying to get into office. But imagine if I was a billionaire making $2 billion a year. Let's see. That's million. 2-3 million. That's billion. If I figured my tax on that, 2 billion at 70%. Then I need counting here. Then that would tell you that you need to pay 1.4 billion of your $2 billion to taxes. There'd be a mass exodus of people from the country. So that even though I'm sure the 70% is still outrageous, they're not talking about your entire amount being at 70%. They're talking about just the amount over a certain value. So they got a name for that. I don't know if it's graduated tax system. Let's see if I remember that right. So few people in life actually understand that. Not progressive tax. Well, maybe it's progressive. No, graduated tax definition. I think it's graduated tax. Okay, but that's what we're going to take a look at. Now, we're going to use these amounts right here. So, to begin with, I need to get the amount from the user. We'll have a console.writeLine. And I'll say input salary. Now, declaring variables, just the same as if you're over in Unity /video, Microsoft Video Studio. We can declare variables. You can do int for integer. You can do double if it has decimals. I'm going to do double. And salary. And I'm going to figure tax. So I'll go ahead and have tax here too. Okay, so when I get it from the user, I'm going to use console.readline to get it. It'll come as a string. Now I could have this separate here, like string s. And I could say s is equal to console.readline, like that. And so it'll ask them to input the salary. The console.readline will get it from them, whatever they put in, and store it in a variable called s, which is a string. Now, I don't want it there. I want it actually in my variable called salary. So here we have to do our double dot parse, and we'll convert s to a double. Again, string we can't work with directly number-wise. This double refers to that structure, And this parse here, you can pass in this parameter of a string. And so now, if I just do a console.writeLine to see what I got,
I need to use the restroom.
okay. Now if I run that, input salary, I put in 3,000, comes back, tells me 3,000. Okay, so we've brought in salary successfully. This is an incremental approach to development. It's where you write little bits of code and you test it as you go along. So I got that part working. I know I don't need to even look at it anymore. I know it's working. Now here I want to do my if statement. So I'll say if salary is less than or equal to 30,000, then I'll put curly braces here. If you have one line of code, you don't need those curly braces. And I'll say tax is equal to salary times 20%. Now, since I don't want to handle, how do you handle all? What if it's over 50,000? I'm going to just say $30,000 and $1 up. Of course, I guess I've left off the decimals, haven't I? But we'll assume no decimals. So if it's not less than or equal to 30,000, which is this case right here, then it'll be this case. So we're going to do an else. Now at this point, no matter what, I'm going to have 30,000 taxed at 20%. So that goes without saying. But I had to figure out the amount over 30,000. So my tax is going to equal to, first off, 30,000 times 20%. So that's that first 30,000. Now remember, if they put in 40,000, I take 40,000 minus the 30,000. So I'm going to put salary minus 30,000 times my 25%. And then I'll do a console.writeLine. And I'll print out tax. Well, it actually helps to know if you're doing it right. So let's see what 29,000 times 20% is. 29,000 times 20% will give us 5,800. So let's run this and see if I'm even close. Okay, comes down here to salary. And I said 29,000. And it tells me 5,800. So that's good. That part's working. Now let's say that I do consider 40,000. Well, the first $30,000 of that is going to be taxed at 20%. So I'll go ahead and put that in there. 30,000 times 20%. Then the next 10,000 will be taxed at the next amount. So that's going to be 10,000 times 25%. And then my total tax, I'm going to add these two together. Should give us 8,500. So let's put 40,000 in and see how it works. Again, how I'm running it as I'm doing a debug, start without debugging. Don't choose to start debugging because otherwise it'll put your answer up and then it'll immediately exit off. So start without debugging. And put 40,000 in. And that gives us 8,500. Now, what I'm asking you to do on the test is just do a simple comparison. So nothing really complex there. And I'm asking you just to print out the result. So like console write line type of deal. So again, if this was my project here for that problem, I would copy it. So I'd highlight it, do an edit copy, go over to Blackboard, paste it into the box, and then below it, I'd write down my result I got. And that would be problem number 1. And that's based upon the if-else construct. Is there any questions on that one? Okay. Let's take a look at a for loop. That's I don't know if it's the second one. It's either second or third. But let's take a look at how a for loop works. For int x equals 1, continue while x is less than 6, and x plus plus. Then I'm going to do a console.writeLine, and I'll print off x. Now what this does is this declares a variable called x, and it's for use within this for loop. So it declares a variable called x, and it assigns it equal to 1. So that's my initialization. That only occurs one time when it first enters the for loop. Then it'll check before it runs. So this will check, is 1 less than 6? It is. So then it'll run the lines of code in here. After it gets done running the lines of code, it'll come and do this. This is your increment, what you're changing it by. Now this here is my check. It returns a true or false. If it's true, then it keeps doing the lines of code here. If this is false, then it drops outside of the for loop. Now if I run this, you see we get 1 through 5. Now with our for loop, this x plus plus here at the end can be any variable or any calculation, sorry, any assignment. So x is equal to x plus 2. So I'll go by 2's then. And if I run that, you see we got 1, 3, 5. This starts at 1, and I add 2 to it. 1 plus 2 is 3, 3 plus 2 is 5, and the next one is beyond the condition here. It's not less than 6, so it doesn't run it. Now let's say I wanted to find a factorial. I think I've shown you that example, but just to refresh your memory. I want to find 5 factorial. And then I'll do something a little bit more interesting. Now 5 factorial is 1 times 2 times 3 times 4 times 5. So we're going to be looping from 1 to 5, which is actually what we have already. When we did console write line, we saw that it's looping from 1 to 5. I do need to change this back to 1, so it increases by 1. Now let's run that and just make sure that's true. You see, you got 1 through 5. Now for our factorial, we'll multiply all these together. So 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is still 120. So that's the answer we should get. So I need to have a variable, and I'll call it fact, where it's set equal to 1. because we're going to keep multiplying over and over. And you have to have it initialized as something. If I have initialized as 0, 0 times anything is 0, so that wouldn't work. Whenever you're dealing with multiplication, you always start at a 1. And then down here in my code, I'm going to say fact is equal to fact times x. So each time through my loop, x equals 1, x equals 2, x equals 3, it'll take the value of fact. First time it's 1. 1 times 1 is 1, and assigns it to fact. Next time through, x is 2. So the old value of fact is 1. 1 times 2 is 2, and assigns it to fact. Now our old value of fact is 2. 2 times 3, I guess is next one, is 6, and so forth. I can, instead of printing off x here, I could print off fact to verify the result. So if I run that, debug, start without debugging, I see it builds up to 120. Now, I want to print my answer down here at the end. So I'll do a console write line, and I'll print fact, like that. I don't need this here anymore, so I can just get rid of that. And then do debug, start without debugging. And we get 120. Now the question on the test for the for loop isn't some extremely complex mathematical formula, so don't stress. Pretty simple math is what I'm looking for there. I just want to see if you can construct a for loop. Now I'm going to calculate pi using a Fibonacci sequence. And that goes like this right here. So let me copy that over, and we're going to see how to implement that. I think there's many different ways of calculating pi, but this is one of them. Now it starts with 4, and then 4 over 3, 4 over 5, 4 over 7. But the 4 here I could put over 1. And so if you look for a pattern, you see it goes 1, 3, 5, 7. It's always 4 on top. So I'm going to have a variable, pi, and I'm going to set it equal to 0 initially. Because we're adding and subtracting. When you're adding and subtracting, you should always initialize your value to 0. Now, I'm going to go from, let's say I go 1 to 7. So I'll continue while I'll start with x equals 1. I'll continue while x is less than or equal to 7. And now I'm going to increase x by 2. Well, let's see what in the world that looks like. And I don't know why I got integer for pi. Pi should be double because it has decimals. But I'm going to print out my values of x to see if that looks right. Okay, so console.writeLine, and then I'll print out x. Now I'll get rid of this console write line fact here at the end, like that. And debug, start with that debugging, 1357. So that looks good. 1357. It is an integer, so I need to keep that in mind, because you have to make sure you don't get an integer division on this. Now, this is negative. This is positive. This is negative. This, if I were to put it, is positive. So the sign changes. So I need a variable for sign. And initially, I'm going to have it equal to positive 1. Because this is positive. So then, if I did my write line, and if I looked at the sign also, included it with this, I would take sign times x. Now how I cause it to flip is I say sign is equal to sign times negative 1. So initially, sine will be a positive 1. So it comes down here, 1 times x. X is 1 to begin with. 1 times 1 is 1. Comes down here. It multiplies the old value of sine, which is 1 times negative 1. 1 times negative 1 is negative 1. So next time through the for loop, it'll take negative 1 times x. Then I'll have negative 1 times negative 1, which gives you a positive 1. That's how you cause those signs to flip. Well, let's run that and see if that's right, what I'm thinking. So debug, start without debugging. Positive, negative, positive, negative. That's right. Now again, this is an incremental approach. Take it a piece at a time. Get each little piece working and then build upon that. Now, if you've had mathematics recently, and most of you have, it doesn't matter whether you put the sign on top or the bottom of a fraction. It's equivalent. So I could leave it that way. So now what I need is 4 up on top. So I need 4 divided by sine times x. Order of operations wise really doesn't matter. I think that's a true statement. Yeah, it's a true statement. But I don't want times. Let me think about this. If I include the sign down there with that, then I want that right there. So I want parentheses around that. So then I'd have 4 divided by 1 times 1. 4 divided by 1 gives me this. When my sign flips, this will be negative 1 times 3. So we got 4 divided by negative 3. Well, let's run this and see if that looks right. Four. Yeah, that seems right. 4 divided by 1 is 4. Negative 4/3. If I plug that in my calculator, I get negative 1.3333, which looks right from this. 4/5. That's 0.8. And negative 4/7, I don't know what it is, but I'm assuming it's that since the first 3 are right. May not be a safe assumption, but we'll go with it. Okay, so now it looks like I'm getting these individually, so I need to add them together. So instead of having a console write line here, I'm going to say pi is equal to pi plus 4 divided by sine times x. And I'll do a console dot write line, and I'll print pi. So we're going to see pi build. I don't think this will work, and I'll talk about the reason why here shortly, but let me run it. 7's probably not enough, but let's go ahead and see what we get. That's strange. I didn't think it'd work. Okay, let's change that to 17. Okay, it's converging closer and closer to pi. Let's change this to 170. Oops. Yeah, it's converging. Change that to 17,000. Hopefully that doesn't run forever. It's taking a little bit, isn't it? You may have been watching this as it's going along converging. 3.14 and it got 1. Next one it should converge upon is 5. It's bouncing back and forth between 3 and 8. There, I think I saw 4, maybe not. Okay, I'll stop that. Let me move this outside the for loop here. Now let's run it. 3.1414. I want 159. So let's put another 0 in here. Goes up to 170,000. 3.1415. Next one should be a 9, I think. So I'd have to take it even more. Put another 0 in there. 3.14159. I don't know anything beyond that, so I couldn't tell you in terms of pi. Now, I mentioned I didn't think this would work. The reason why is because this right here is an integer. 4 is an integer. Sine. Oh, no, I made sine a double. Never mind. The fact that sine was a double is what caused it to work. If, on the other hand, I had made this an integer, I doubt seriously it would have worked at all. Comes up as 3. That's our estimate of pi. Reason why is if this is an integer times an integer is an integer. 4 is an integer. Integer divided by an integer, it does integer division. It doesn't do double. So you get around it different ways. You can make this double, like I did, or if you put a 0.0 on one of them, if you got a number there, so that especially works. It doesn't work with x or sine. This will be a double by putting a 0.0 on there. And so now if I run it, you see it works. That's a common technique you see in programming, is if you want a double result, you can just simply put a 0.0 on there. You can also cast it to change the type of the variable, or you can change it just as declare one of them to be a double to begin with. I can simply, like I said, put a double here. And then that'll work. But that's how to do a for loop. There is some issues when you have too many doubles, how you have some precision errors. We don't really cover that in this class. That's more of an advanced computer science class where you look at that. But anyway, that's our second example of a for loop. Is there any questions on the for loop? Again, don't stress. I'm not going to be giving you a hideous calculate pi to 50 decimal places type of problem. It's very basic. I just want to see if you know how to do a for loop. Well, let's take a look at the while loop now. And I'll come back to that. I'm going to recalculate pi. And we'll calculate 5 factorial again, which we said was 120. And again, it's 1 times 2 times 3 times 4 times 5, or 120. Factorial is a very common one, and I could put that on the test, but that's also one that you can Google and find really easy. I'd be surprised if you could find the one I put out there real easily. I mean, it's not a hard programming project, but it's just like, who would ever want to post this out there on the internet? Not saying anybody would look for solutions on the internet, but I choose something like that so that I know you're writing it. Okay, so for 5 factorial, I want to say while x is less than or equal to 5, because I want to loop from 1 to 5. And we want our beginning brace and our closing brace. I'll be right back. I need to grab a drink. I got to bring my pop to class. I'm back. Okay. Now, this in our while loop is the check. This tells us when to stop our while loop. So while x is less than or equal to 5, it's going to continue that while loop. Now, for a while loop, we have to have for our initialization separately. It's not like a for loop where you put it on the same line. So we'll put that separate. We'll initialize x equals 1 because we want to loop from 1 to 5. You also need to have your assignment operator down here. X is equal to x plus 1. So this is going to increase x by 1 each time. Or you could do x plus plus. Again, let's do our console.writeLine and print out the value of x. Just to make sure that we got everything right there. Do a debug, start without debugging. Then we see it loops from 1 to 5. So that's right. Well, just like before, we need a variable fact set equal to 1. Now, since I know this is right here, I could get rid of that. And I'd say fact is equal to fact times x. Same logic as before. And then down here, I'll do my console.writeLine and print my factorial. Now let's run this. Then we got our 120. So again, the different components of a while is you have to have your initialization outside of your for loop. So you have it up here. You have your Boolean check here. So this is just returns true or false. And then you increase x down here. Now there's different ways of increasing x instead of doing it that way. Some people will put like a plus plus up here. Now I don't know if that's the correct place to put it. We'll see. I think it'll still work because I think it'll increase x before it does a condition, maybe after. But either way, it should work. But let me see. 720. That doesn't work. Let me put the plus plus before it. I'm not very good with putting that up there. 120. I can fumble around and get it. So, and sometimes you can include it up here. That doesn't do you any good if you're not increasing it by 1. If you're increasing it by 2 or some other factor. I think it just keeps it a lot simpler if down here you say x is equal to x plus 1 or x plus plus. Now, that's our first example of a while loop. Let's take a look at programming E. In mathematics, has 2.7 and a bunch of decimal places. That's assuming I can find the formula for it. Calculating exponential E with a sequence. It may not be like mathematics, or like pi, I mean. Interesting. Oh, that's just different formulas. Never mind. Calculate exponential e with in a program. In a computer program. If I can't find it, I'll just go back to pi. Taylor series. It's been a while since I've taught Calc 2. Site can't be reached. Okay. Yeah, here's e to a power. So we'll use that Taylor series. Go away. Looks like this program we need the factorial back. So I could probably leave the factorial there. And this just doesn't ring any bells at all for Taylor series. But we're calculating e to the first power, which is e, which means our x's get replaced with 1s. So we got 1 plus 1 over 1 factorial plus 1 squared over 2 factorial plus 1 to the third over 3 factorial plus a bunch of dots. Keeps going forever. Which is e to the first power is equal to 1 plus 1 over 1 factorial plus 1 divided by 2 factorial plus 1 divided by 3 factorial, so on forever. Now, I don't remember the Taylor series for anything. You know, I haven't taught Calc 2 for 8 years, 9 years. Doesn't matter in programming. You look for patterns. Now, question would be if I could put a 0 factorial here. And I can. Mathematics-wise, 0 factorial is equal to 1. So 1 divided by 1 is 1. So I can tell from looking at this, the 1 is always set. But my bottom number changes. It goes from 0, 1, 2, 3, and so forth. Now I could, if I wanted to, ignore this first one and just initialize it to 0. Or to 1, I mean. But we'll leave it there. Okay, so I'm going to calculate E, and I'll say, what we'll call it, EXP. And since I'm adding, subtracting, I'll set it equal to 0 initially. And I'm going to get rid of factorial here. I'm going to come back to it. We want our program to go from 0 up to, let's say, 3. So x should start at 0, and I want it to go up to 3. Well, let's first see if we got that part working. Console.writeLine, and I'll print x. Now if I run this, obviously don't have it right. Oh, I got rid of my increasing x. Okay, let's try that again. X is equal to x plus 1. Now let's try it. 0, 1, 2, 3. 0, 1, 2, and 3. Okay, so I got that bottom part. But now I need to calculate the factorial of that number. So up here I'll declare factorial as an integer. And for each x, I want to have a loop in here. And we'll use a for loop. It's as good as any. I'll set fact equals 1. For int, I'll use y equals 0. Continue while y is less than or equal to x. 0. I want it to be 1. Continue while y is less than or equal to x, and do y plus plus. And fact is equal to fact times 1. What does this mean? Well, 0 factorial is 1. Let's see if that even works on 0 factorial. If I have x equals 0, yeah, factorial equal 1. So that'll work. If I have, let's say, 3 factorial. So x is 3. Comes down here. It starts at y is equal to 1, continues while y is less than or equal to x, which is 3, and then increases that, and then multiplies fact times 1. Where did that come from? Fact times y. So now, I know this is correct, but I'm going to leave it there for the time being. Console.WriteLine, and let's print y. Now, 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6. So what I should see is those numbers, or I should see an error. What did I do wrong? It does not exist in the current context. Oh, fact. Do debug, start without debugging. 0, 1, 1, 1, 2, 2, 3, 6. Okay, that looks like it's working. Okay, so I get rid of those. What I've just calculated with that factorial is I calculated this bottom part. So then I need to do 1 divided by factorial. So I'm going to say exp is equal to exp plus 1 divided by factorial. There's a problem with this, though. 1 is an integer. Factorial is an integer. Integer divided by an integer is going to do integer division. I can get around that by putting a 0.0 on there. And I'm like something. Oh, I said exp was should be a double. And then I'm going to do a console.WriteLine. And I'll print out the value of fact. Now if I run that, that still doesn't look good. Oh, I need to print out the value of exp. That's better. 2.66. I don't know what E is equal to, actually. .718282. So obviously need a lot more iterations than that. So I could have this go up to 3,000. If I run that, infinity. That's not good. Oh, because it became too big for a factorial. Oh, that'd be a challenge. Try 300. $30. I never thought about that. That 2.71 8282. Close enough. What the problem is when you do a factorial and you do like 6, that should give us 120. 720. Yeah, 5 factorial. The one we just did is 120. If I do a factorial of 3,000, it doesn't handle numbers that big. 300 doesn't handle numbers that big. So it turned to infinity for whatever reason. You get around that by putting a bigger integer in there. I don't know if they got a long. What is long? Fact. Represents a 64-bit signed integer. Questions if I go up to 300. I'd still be doubtful. Nope. It goes up larger. What do they just use? If I just use double. Okay, that looks better. So it looks like it converged upon a number. That one is, like I said, that's a pretty complex example for the while. What I'm looking for math-wise is pretty straightforward. You don't have to do any kind of special math at all besides just your basic operations like add, subtract, multiply, and divide. Is there any questions on the while loop? Well, like I said, I've already put the test out there. It is time, so I'll give you the rest of this time to practice on for loops, while loops, whatever you want to do on that. If you want to go ahead and start to take the test, just make sure you have a total of hour and 20 minutes available to finish the test. It does not allow you to complete part of it today and part of it tomorrow. So it has to be completed in one sitting. On Thursday, we'll get back to Unity, the fun stuff. Is there any questions on the test?
I have no idea what I'm doing, so should I still, I can try to find time to do it, but should I attempt it or?
Well, I wouldn't attempt it now. Do you need to see more examples of a for loop and while loop, or?
I don't know any of this. I hardly know coding in general. I just know a few basic things.
I would start off by practicing the ones that I've created, and don't do the math ones I've shown. Just start off like the factorial one. Try to create a for loop and a while loop where you're looping from this number to this number and print out the results. Try adding them. Try to multiply them. Subtract them. And if you need more time than I put the due date down for this Sunday, if you need more time than that, then I have no problem with that.
Okay.
And then each time, if you need some see more examples, like next time you come in and say, I played with the for loop and while loop, and can I see a couple more examples? I can make up as many examples as you need to see.
All right.
Yeah, definitely start with that first example I gave you where I just print the numbers, and then get that working, and then go from there.
Okay.
I'll go ahead and stop the recording there, and I'll stay online here. So if you